Hello everyone, I'm Peijun Zhang. My project aims to investigate the performance disparity between two dominant dimensionality reduction techniques, PCA and t-SNE, when dealing with complex nonlinear data structures common in the real world. Here is a quick overview of the main components of this project. The curse of dimensionality remains a significant hurdle in data science, impacting efficiency and interpretability. While we use DR to mitigate this, the chosen method must preserve the data's true underlying structure. PCA, the linear method taught in many curricula, is fundamentally limited by its linearity assumption. This limitation causes it to fail when faced with complex manifold structures like the Swiss roll. This research quantitatively validates the necessity of using the nonlinear alternative t-SNE. PCA excels at computational efficiency and preserving global variance. However, its linear constraint is shortcoming. It collapses curved structures, leading to a loss of essential information. t-SNE uses a probabilistic approach to focus on local relationships. This mechanism allows it to successfully unroll nonlinear structures, producing high-fidelity visualization. Our experiment utilized the classical Swiss roll dataset, a 3D nonlinear manifold that serves as the ideal test for an algorithm's ability to perform nonlinear unrolling. This study compared the performance of both algorithms in reducing the data from 3D to 2D for visualization. Also, adopted the trustworthiness metric to quantitatively measure the preservation of local neighborhood relationships, which is central to validating our hypothesis. Let's look at the PCA result. When applied PCA, the embedding shows a distorted spiral projection. The linear projection caused the manifold layers to collapse. This visually supports the hypothesis derived from research question 1. The low trustworthiness score of 0.8645 quantitatively confirms this collapse and the poor preservation of local neighborhood structure. Next, we observe the t-SNE result. We can see that t-SNE perfectly executed the unrolling task and successfully transformed the 3D manifold into an interpretable 2D embedding. With high clarity and continuity, the high trustworthiness score of 0.9996 is near perfect, strongly supporting the hypothesis for research question 2, demonstrating t-SNE's superior effectiveness with nonlinear data by preserving local relationships. In conclusion, this study strongly validates that the nonlinear approach of t-SNE is indispensable when dealing with complex nonlinear manifold data, and it cannot be replaced by linear methods like PCA. PCA's linear constraint renders it ineffective against nonlinear structures. t-SNE, by prioritizing local neighborhood preservation, accurately recovered the data's true structure. This underscores the critical importance of selecting the appropriate dimensionality reduction tool for accurate understanding and interpretation of complex datasets. Thank you for your listening.